Okay. So what we've got today is the laws of indices, or we can call it the laws of powers. Okay? So when we talk about indices, we're talking about a number carrying a power. So if we say a to the power of 2, okay, this is called a base, okay, and this is called a power, okay. The understanding of these two things are very important, okay. Same thing if we have 2 to the power of 3, what's carrying it is the base, and that's the power, or some people call it index, okay. So we're going to go into the laws of indices that are relevant at this stage. Now, we have a to the power of m times a to the power of n. This rule of indices states if the base is the same, we just take 1 and then we add the powers. So that's a to the power of m plus n. And how do we apply this? So if we had numbers in place, if we said a to the power of 2 times a to the power of 3, the way we would solve this is a to the power of 2 plus 3, which is equal to a to the power of 5. Now, if you ask yourself why does that work, a to the power of 2 is a times a to the power of 3, that's times a times a times a. And so what we do is we count the a's, 1, 2, 3, 4, 5 being multiplied together, so that's a to the power of 5. So instead of going this long route, we just do this using the laws of indices. That's one law. Okay, we can do it with numbers as well. 4 to the power of 3 times 4 to the power of 5. And that's equal to, so they have the same base, so we just take one of it and then we add the powers, which is equal to 4 to the power of 8. Okay, now a to the power of m over a to the power of n, which is the same as saying a to the power of m divided by a to the power of n. Because they have the same base, we take just one and then we subtract the powers, m minus n. So how does this work? So we say a to the power of 5 over a to the power of 1. Okay, remember that a to the power of 1 is the same as just saying a. We've just exposed the powers in this question. So that means that's a to the power of 5 minus 1. Because they're the same base, we just subtract the powers. So that's a to the power of 4. Okay, now the reason why this works, because a to the power of 5 is multiplying a 5 times divided by just a to the power of 1, that's just 1a. So we cancel out this a with 1a, and how many a's are left? 4 of them. So we cancel out for 1 and 1 actually. And so when we multiply 1 times a, that's a, and so there's a 4a's, so that's a to the power of 4 over 1 at the bottom, which is just a to the power of 4. Okay, so this is the long route, or instead we could just use the laws of indices. When we have the same base and we're dividing, we subtract the powers. Okay, we can do this with numbers as well. 5 to the power of 6 divided by 5 to the power of 4. That will be equal to, they have the same base, which is 5, and so we just subtract the powers at the top. 6 minus 4. That would be equal to 5 to the power of 2. Okay. Now, a to the power of m with n outside the bracket. There's already a power and then another power outside the bracket. What we do is we say a to the power of m, the power inside the bracket, times the power outside the bracket. Okay? So, how does this work? If we say r to the power of 2, bracket 3, power outside, that's saying r to the power of 2 times 3. That's r to the power of 6. Now, if you consider the long route, r to the power of 3 of r squared, meaning you multiply r squared 3 times, so that's r squared times r squared times r squared. And what's r squared? R times r times another r times r times another r times r. How many r's are we multiplying together? 1, 2, 3, 4, 5, 6. So that's r to the power of 6. So we can use the laws of indices, which is shorter, or go the long route. Okay? Now, we can also do this with numbers. So we can say 11 to the power of 6, okay, in the bracket, and we can have a fraction of power on the outside of a half. And so the process doesn't change. That's 11 to the power of 6 times half. Okay, that's 11 to the power of 6 over 2, depending on how you approach that, and you end up with 11 to the power of 3. Okay? Now note, 4x squared is not the same as 4x in bracket squared. In this case, the squared only is for the x. In this case, the squared is for the x and the 4 as well. Okay? We'll come to that when we're solving more questions regarding this. Now, for this one, a to the power of 0, it's simply 1. Okay? Because the rule is anything to the power of 0 is 1. 11 to the power of 0 is 1. 1,000 to the power of 0 is 1. 1792 to the power of 0 is 1. R to the power of 0 is 1. If you finish solving a problem and you end up with a base to the power of 0, say 7 to the power of 0, it's 1. Okay? Very important. Finally, anything to the power of 1 is itself. A to the power of 1 is A. 7 to the power of 1 is 7. R to the power of 1 is R. M to the power of 1 is M. Okay? Anything to the power of 1 is just itself. You can just hide the power. Okay? Now, there are other laws of indices, but for the scope at this level, this is what we're going to be dealing with for now. Okay? So, the laws of indices are not things to be put aside. Okay? You should have them on a piece of paper, and anytime you solve any indices questions, you should have them next to you, comparing them to each question. Okay? And if the question looks like the rule, or the law as we call them, you can use that law for that question. Okay? When we deal with questions in the following session, you will see how all of that works. Okay? Go through the rules, make sure they sink in, put them on a page, and keep them. Okay? Thank you very much. You've been listening to the Math Done, and until next time.